Okay, so you said Becky, I forgot what you said. 12.3. 25, I think you said, right? Okay. 12.3 times 25. And we have 32 raised to 2x minus 3 equals 2. In this case, we have to present both sides with the same base. So all we have to do is replace 32 by 2 to the 5th. So 2 to the 5th, everything raised to 2x minus 3 equals 2. I copy the base. What happens to the exponents? Yes, I will multiply or distribute 5 to these two. So 10x minus 15 equals 2, or 2 to the first power. So two numbers are equal and they have the same base. What has to happen? Two numbers are equal and they have the same base. Their exponents have to be the same. 10x minus 15 equals 1, or 10x equals 16, or x equals 16 divided by 10, and I have to simplify. So I get 8/5. Is this okay? Okay, I didn't do anything to them. So let's discuss this one more time. Two numbers are equal and they have the same base. Their exponents have to be the same. So I said the exponents equal to each other. I did not simplify the twos, they didn't do anything. If the numbers are equal and they have the same base, the exponents have to be the same. Other questions? Okay, so can I choose problems now or you? Is there something else? Is there something else? You had something else? Sure? Okay, so let's look on page 773. This is the review for entire chapter 12, but I'm going to select only from those 5 sections. So let's say we are given f of x, which is x squared minus 2, and we are given g of x, which is x plus 1. We are given h of x, which is x cubed minus x squared. And we're asked to find the function composition, and I'm going to choose a couple. H comes g of 2, that's one question. F comp g of negative 1, and h comp h of 2.
Is this a review for chapters 7 and 12?
Yes, the test 4, yes. I started with chapter 12. And then we'll go back to chapter 7, correct. let's start the first one together, and then you'll do the other two on your own. So when I'm asked to find a h comp g of 2, what am I really asked to find? H of g of 2. Where is the starting point? Of course, from the inside. I have to find g of 2 first. Okay, so can anyone give us g of 2?
3.
Exactly. And now I know what I have to determine. I have to determine, yes, Becky? Yes, so I have h of 3, right? Which is 3 cubed minus 3 squared. And the solution is? Excellent. Good. So let's find f comp g of negative 1, and then h comp h of 2. Awesome. And I'll put my attendance in. Allow me to remind you about the student opinion form, so please, if you could, only 3, fill those out, please. I'm sorry? That's okay. Yeah, so please, they're only open to you till Sunday, I believe. Beyond Sunday, you will not have access to them anymore. So this is f of g of negative 1. So we have to determine g of negative 1, which is 0. And then we have to determine f of 0, which is negative 2. Awesome. And on the last one, h comp h of 2. This is h of 2. Is this okay, everyone? What about h of 2? Eight minus 4, right? Which is 4. So this is h of 4. And that will be 64 minus 16, which is 48. Do we all agree with 18, negative 2, and 48 respectively? Yes? Yes? Okay. Next problem. We are told that the function is 1-to-1. And I'm looking at problems 15 and 16 on page 773. We're given f of x equals the square root of x plus 2. In problem 15, did we do this before? Problem 15, we're asked to find in part A f of 7, and in part B f inverse of 3. There is no need for parentheses in front of that. I don't know why I put it there. Okay. And in 16, we're asked to find f of -1 in part A, f of -1. And in part B, we're asked to find f inverse of 1. For the same function, both questions 15 and 16 refer to the same question. Okay, can anyone give us f of 7? You agree with 3? Okay. This function is 1-to-1. We know its graph by the horizontal line test is 1-to-1. Now I'm asked to find f inverse of 3. I don't have the inverse function, and I don't have to determine it. But is there a way of determining f inverse of 3? Which is, if the function is applied to 7 and returns 3, the inverse function is applied to 3 and returns 7. Very good. That's the answer is 7. What about number 16? F of -1. F of -1 is 1. And then f inverse of 1 must be -1 indeed. Awesome. Okay. So here is 28. We are given f of x equals 13x minus 5 divided by 2. What type of function is this? It doesn't have x in the denominator, so it's just linear, because I can separate it into 13 halves x minus 5 halves. So this is a linear function. Is a linear function 1-to-1? Yes, by the horizontal line test is 1-to-1. So let's find f inverse. It's a 4-step procedure. So let's find f inverse. Now you have to show all the 4-step procedure. For the inverse? Yeah, you have to put in writing 4 steps. Can anyone remind us the first step? Right, which is allowed because they are the same. That is the first step. What is the second step?
Switch x.
Yes, and we know why. Now we are solving for y. So let's solve for y. Now you can say this is a proportion. Or you can just say I multiply both sides by 2. That's fine too. Same thing. So if we multiply both sides by 2, we get what? 2x equals 13y minus 5. And now I'm solving for y. I have to add 5. And finally, when I solve for y, what do I have to do to both sides? That's it. 2x plus 5 divided by 13. And this is f inverse. F inverse of x, 2x plus 5 divided by 13. Becky, is this what you wanted to say?
Yes.
Awesome. But you have to show it. Please show it. Okay. Problem 30. we are asked to graph f of x, which is 5x minus 5, and graph its inverse. We're not asked to find the inverse. We are given a function. What type of function is this? Linear. Is it 1-to-1?
Yes.
Yes, by the horizontal line test, the linear function is 1-to-1. Is the quadratic function 1-to-1? No. Perfect. So we are given a function, we know it's 1-to-1, we know it will have an inverse function. We are not asked to find the definition or the equation of the inverse function. We're asked to graph this and this function and its inverse on the same coordinate system. So let's do that. Yes, you do. Thank you. Since it's linear, how many points will you determine? How many points do you need in order to graph this function?
2.
2. The recommended ones, please, are the x and y intercepts. Okay, can anyone give us the starting point to find the x and y intercepts? I start with x equals 0, and then y is
-5.
good. So the ordered pair is 0, comma, -5. Now when y is 0, 0 equals 5x minus 5. I move 5, so I get at x equals 1. So the ordered pair is 1, comma, 0. We agree with that? So it's right here. I graph the function. So f of x equals 5x minus 5. We know it's 1-to-1. We know it has an inverse. We have not asked to find the inverse function, but we're asked to, yes? So, but we're asked to graph the inverse function. Can anyone give us 2 points that we will use to graph the inverse function? Very good. -5 and 0. It's the reflection of this with respect to which line?
Y.
Indeed. So now at this point I can graph that line. Yes, Becky, go ahead. And the other ordered pair is
0,
0, 1. So this must be a point that belongs to both. If the function crosses the y equals x at a point, remember 3, 3. If you reverse it, has to be part of the other graph as well. 2, 2. If you reverse it, still has to be part of the other graph. So this is whatever the inverse function is, which I don't care because we are not asked to find it. We can But this is how I graph both on the same coordinate system. Okay, so let's solve few equations, exponential equations. Let's start with 36. 8 raised to 3x minus 2 equals 4. We just had a very similar problem a few minutes ago. And then I would like to look at 33 as well. 2 raised to 3x equals 1 over 16. So let's work on these two equations. So what is the idea here? What do we want to accomplish as the first step? We want to present both sides with the same base. Okay, so let's do that. That's the idea. There are, as I mentioned last few weeks, there are situations in which you cannot do that. You have 2 on this side and 3 on this side. But that is a different procedure that we will study in the next course. And which is your next course, by the way, if you want to tell me. You don't have to. Say it again. Pre-calculus? 137. Okay. It's college algebra, actually. I think I teach one of those if you're interested.
Well, I'm doing it online.
You're doing it online.
Yeah.
Okay. Yes, I remember you said that. Anyone else? Mike, what are you?
I think I'm taking 145.
That's pre-calculus.
Yeah, I'm taking 145.
I don't know if I have a 140. I don't think I have one. The other option would be, remember 145 with 146 are the same with 151. But it's a lot of work in 151. No, they didn't give me 145. They gave me 151. 151 Mondays and Wednesdays from 5 to 6:45 in this building and room. Matt, what are you doing?
Whatever the first math is in the computer science transfer degree program.
Yeah, basically that's what I'm doing.
145?
Yeah, it said if you get a C in here, then you
Yeah,
go to
that's
145.
You're expecting a C in this class? That's my answer. You're not working for a C in this class, are you?
No.
Okay.
I mean, but I'm just saying like that's like
The
off
required
the
minimum requirement for that
yeah
class.
to go to.
Okay, I feel better now. I take this back.
It's like the way you progress through the transfer program is that you would go to 145.
I see. And you transfer after 145? Or you still have to
No,
take 146?
I'm not sure what I take after because I'm doing a 2-year transfer program into UMBC, so I'm not
But
sure what they're gonna.
Before you register, just make sure you look into this because you can finish one. But again, this is a tough course. A lot of work. So you have the option of 151 or 145 plus 146. So this is 6 credits and this is 4 credits. But this is in 1 semester and this is in 2 semesters. And you could say, well, this is too fast for me. I prefer this, and I understand that.
the same material,
It's the same material.
Just in one semester.
It's just 1 semester.
which is college algebra, you said.
No, 145 is pre-calculus.
Okay.
This is accelerated pre-calculus because it's everything in one. But again, I'm not forcing anyone, if you know what I mean. You have to make the decision because you have to do the work.
I tried to take calculus in high school.
Say it again.
So I tried to take calculus in high school. I think I dropped.
I kill myself working and going to
Well, with your study skills today, you should not have it.
Yeah, it's much easier now that you're not in high school.
Right.
I don't even know
Much
why
better
I
That's
started
good.
taking, because I did like regular pre-cal, maybe.
I got a B minus in pre-calc.
Yeah, and then there's like AP pre-cal, crazy, whatever.
Well, as I said, if you are, yes.
I was such a bad student.
I feel like I was pretty good.
The 2 is 2 and 1 over 16 has to be
That made me feel like I was good.
So moving into a class like moving.
Say it again.
How do you figure it out? What this-
Because it's a fraction and it has to have a base raised to a negative exponent. So, say it again. So 2 to negative 4 is 1 over 16.
How do you figure out what it's square of?
No, I know that 16 is 2 to the 4th. You're not squaring. You're just replacing 1 over 16 by 2. You're not squaring. Okay, so let's start with the first one. I saw very good. So 8 is replaced by 2 to the 3rd, everything to 3x minus 2, and 4 is replaced by 2 squared. And yes, we copy the base, multiply the exponents, correct? 9x minus 6 equals 2 squared. Now we have the same numbers, they're equal, the same base, so 9x minus 6 equals 2. And 9x equals 8, x equals 8 over 9. Do we accept this? Okay, now the other one, the left-hand side is 2 to 3x, and the right-hand side is 2 to negative 4. Do we agree so far?
Did we go over that? I know we did like how to
Yes.
make them into that,
Yes, we did go over exponential equations.
but I mean I know we did because it's like when you have a negative exponent you put 1 over and all that. But how do you go from the fraction to find the negative exponent?
Because I know that 16 is 2 to the 4th, and 1 over 2 to the 4th is 2 to negative 4.
Oh, okay. Okay.
Better? Okay, so then 3x equals negative 4. Or x equals negative 4/3. Agreed? These are exponential equations. Okay, let's graph a exponential function. So I'm hoping that Thursday we will not have to review chapters 12 and 7, and we review the rest. Is that okay? Okay. So let's say we have a y equals 2 to x minus 4. Let's say we are asked to graph it. So I highly recommend the chart with the ordered pairs. Always f of x or y. Always do that. What is the domain of the exponential function? I know non-mathematically I call it friendly so that you remember that it's defined everywhere. It's not like the rational function that could have 0 in the denominator, or the square root, or log, which is not defined everywhere. But this is friendly, so it's defined everywhere. Yes, any questions? Okay, so now let's pick some values. Well, I know how to graph 2 to the x. Let me just refresh your memory on something. Is it a function that is increasing on all its domain, or a function decreasing on all its domain? Right, because the base is greater than 1. Yes, so it looks like this. And now the function that we have here is 2 raised to x minus 4. Where will the graph, so I'm changing x into x minus 4. Where will the graph go? Will it go to your left or will it go to your right? When I change x into x minus 4. And it's easier to see this mechanism with x squared. Okay? So for a moment, let's deviate for a second. So if I have x squared, I know this is the simplest possible quadratic function. We discussed this in chapter 11. But now if I want x, let's say x minus 4 squared, where will the vertex move?
Sorry.
To the right. Exactly. So 1, 2, 3, 4, and this will be the x minus 4 squared. So then where will 2 raised to x minus 4 go? To your left, to your right, or to your left?
Alright.
Yes, 4 units. So this point from 0, 1 will go 1, 2, 3, 4 to 4, 1. I have to copy the function as is. Everything is the same. 2 to x minus 4. But let's say I don't know this. If I don't know this, then I will have to pick some values. Like, for example, negative 1, 0, 1, 2, 3, 4, 5. And see what happens. Yes, I can use the graphing calculator and put in the function. Sorry, I did something else with my students here. So I have to change this back to function. Okay, so let's go to y equals and put this function in. 2 caret, please put parentheses, x minus 2. I'm sorry, x minus 4. And then go to second and table. Of course, I forgot, they always goes back to default. Okay, second and table. And just plug in those numbers. You don't have to calculate by hand. So negative 1, 0, 1, 2, 3, 4, 5. And I copy those in the chart and put the ordered pairs. I already have the graph. This is the graph. Do not be fooled by the graphing calculator. The function does not touch the x-axis. It will eventually, maybe, but not as it shows here. Not at all. So we plug in. I have negative 0.03. There is no way I can present this on my graph. Of course, everything is positive. 0.06, and at 1 is 0.125. At 2 is 0.25. At 3 is 0.5, and then 1, and then 2. As expected. So that's the graph. Very difficult to plot these, right? Maybe 2, 2.25, 3.5, and 4, 1 that we already had. This is what I would do. Use the formula A equals, so problems 41, 42. Let's say 42. A total of $800 is invested in a 7% certificate of deposit for which interest is compounded quarterly. Quarterly compounded interest. Find the value that this certificate will have at the end of 5 years. The formula will be given to you. So A equals P in parentheses 1 plus R over N raised to NT. We have to identify the given information. I don't know which one is what. So let's do that first. Okay, so what is P? Awesome. What is N? 4, quarterly. What is R? 0.07. And again is 4. And what is T? 5. So let's write it and then plug it in. 800, 1 plus 0.07 divided by 4. And 4 times 5 is 20. So let's put in the graphing calculator. So 800, and the number of times the interest is compounded per year. Quarterly, there are 4 quarters. So n equals 4. Is that okay? So 1 plus 0.07 divided by 4, close the parenthesis, caret, I always like parentheses, 20. And we get 1131.82. 1131.82. Okay. Okay, so now we have to solve a few log equations. So let's say page 774. Log, natural log, so I'm looking at problem 87. Natural log of 2x is 2. I don't know how to solve this, but I know it can be replaced by an exponential equation. This is a log equation. Now I need to change into an exponential equation. Yes. How do I write it? What is the base of natural log? ln. I don't see the base. What is it? E. Very good. So then e raised to the second power equals 2x. All I have to do to both sides to get x by itself is divide by 2. This is the exact answer. You could approximate it if you wanted to. I prefer the exact answer. Okay, let's go and use the change of base formula for finding, let's say, log base 1/2 of 3. Now some calculators, I don't know if this software, let's see. Yeah, it does allow you to put it in, and I'm fine. If you have the feature, it's fine. If not, yes.
What number is 87 on? What pages?
774. So you can, so in this case, the base is 0.5, and the number is 3, and press enter.
How did you get to the
Go to math. You may not have this feature. This is kind of new. And go up, and it's choose A, uppercase A, log base. You don't? That's okay. That's okay. So here's the change of base formula. Yes. Becky, go ahead. Okay, so the change of base formula, since the regular calculators only have base what and base what? Base 10 and base E. Awesome. It doesn't matter which one you use. As long as you have a ratio, let's say, let's use natural log of what at the top? of the number I need to determine log from. And the denominator is also the same log, but this time of the previous base, which is 1/2. And you will get the same number. I don't remember what I got. negative 1 point.
5.
Okay, approximately. How will you check? I'm not certain that this is the correct number. Maybe I forgot the formula. I don't know. So how do I check this? I raise
1/2 to the previous.
exactly to get what? Exactly. Say it again. Okay, so then 0.5 in a second, caret, the previous answer, and then I have to, when I hit enter, I should get 3. Yes, which part? What happened? Oh, well, we moved on to the next problem. That's it, that's the answer there. So this was another question, how to find log base 1/2 of 3. Okay, let's look at one more word problem here. We're asked to use the formula A equals P times E to RT to solve the interest problems in which interest is compounded continuously. So this is for continuously. I divided natural log 3 over natural log 1/2. So plug it in the calculator, natural log 3, close the parenthesis, divided by natural log 0.5. So continuously meaning every second, okay? Everything is the same, just that there is no n. There is no number of times the interest is compounded per year because it's done continuously. So this is the principle. Of course, this is the rate, the annual interest rate, and this is the time in years. Same meaning. Find the amount to which a 900, and this is problem 96. An investment of $940 grows if it is invested at 4%, compounded continuously for 3 years. Compounded continuously for 3 years. What will be the formula in this case? A equals 940 times E raised to I can, yes, it has to be 0.04 multiplied by 3. You don't have to multiply it right there if you don't want to, but please put parentheses for the power. Say it again. So we have 940 times E, and in parentheses, 0.04 multiplied by 3. So it reaches 1059.85. And that's the formula for continuous compound interest. I can't think of anything else in here unless you want to practice of any kind, any particular type of problem. Is there a particular type of problem that we want to go back and practice? Oh yeah, I want to determine a couple of functions, addition, subtraction, and their common domain. Okay, so let's say f of x equals x squared minus 1. I'm just making this one up. It's not in there. And g of x equals 3x minus 2. Say it again. Oh, E is with the low T, and this is right here, E to the X. Yes, second and natural log. Yes. So we're asked to find f plus g of x, we're asked to find f minus g of x. We're asked to find f g of x and f over g of x. And of course, their domain and common domain. And now I can say that I can't think of anything else to do here. Maybe also to change an exponential equation into a log and vice versa. We did one, but we can go back and do more. And then we can go to chapter 7. We reviewed chapter 7 at least once, so we can go back and you'll tell me what we need. So first we have to start by finding the domain of these two functions, and then the common domain. So what is the domain of function f? Domain of function f is all real numbers, correct, right? Domain of function g, all real numbers. So then what do we conclude about the common domain, which will be the domain of the sum, so for the sum, for the difference, and for the product. I don't have to write it again. What will be the common domain? All real numbers. Awesome. Good. So now I have to write the definition. So please always write it. Write f of x plus g of x, and then copy x squared minus 1 plus 3x minus 2. Yes, please arrange it in descending order of the powers of the variable. And you will write x squared plus 3x minus 3. And this is the sum. So this is the function that adds those two functions. Would you agree? Is that okay? Becky, are you okay? Are you still on E? Did you find this? Did you get the same thing? Yes? Oh, you're way ahead. That's fine. That's fine. Common domain. Yes. C, D. Common domain. The domain of function g. Okay, so let's look at the difference now. Let's write f of x minus g of x first, and then carefully copy, put parentheses so you don't forget to distribute to both terms, because it's very easy to make a mistake here. So then write x squared minus 1 minus 3x plus 2. And then you will write x squared minus 3x plus 1, and this is the difference. Is this okay for the difference? Okay, for the product, f of x multiplied by g of x. Write the definition first, and then we have x squared minus 1 multiplied by 3x minus 2, and yes, I have to multiply. So x squared times 3x I get 3x cubed, x squared times -2, -2x squared, -1 times 3, x, and -1 times -2, which is +2. So that's it. There is nothing else. They are in descending order. I can combine like terms. One is with x cubed, the other one x squared, x, and 2. Okay. Finally, I have f of x, which is x squared minus 1. Oops. F of x equal over g of x. So it's x squared minus 1 over 3x minus 2. It is very clear why the domain of this function will not be the common domain. Why? Exactly. So here the domain will be -infinity to 2/3 union 2/3 to infinity. Now, can you tell me what would you prefer to do from chapter 7? If not, I would like to go back and review other things for the final exam. Because we did review, but it may not be enough.
This chapter's not a little bit, if we really like that.
Say it again.
So this chapter's not a little bit, if we look like that.
Yes, in which we add, subtract, multiply, divide, in which we have those complex rational expressions, in which we solve rational equations. Yes, perfect. Yes. Which one, which type of problem would you like to start with? Or if you want, I can choose. Yes. Yes. Just give me an example so I know exactly what, or any problem. Yes, just choose any problem so I know exactly what I should address. Just choose any problem you are looking at. Any problem. So I can answer exactly to that particular topic. So you said 7.4 and 7.5? Okay, just, you want me to choose? Okay, very good. So in 7.4, so let's look at problem 44 on page 506. So we have x minus 1 divided by x squared minus 2x plus 1, and then minus x plus 1 divided by x minus 1. We're asked to perform the indicated operations. Your book will not say state restrictions, but I kindly ask you to. So let's take a minute, work on this, and then we'll do it together. Can at least anyone put us on the right path for this? Or what would be the first step? Exactly. I have to factor the denominator. Awesome. Yes, it's from 7.4. So how do we factor x squared minus 2x plus 1? This is the formula that we discussed on the first day of classes. Yes, thank you. How many restrictions will I have to write then? 1. Very good. Good. So what is the LCD? Exactly. All different factors taken at their highest exponent. Not adding exponents, but a highest exponent. Awesome. So now what are the adjustments? What is the adjustment for the first and the adjustment for the second, for the numerator only, of course. For the first one, 1. For the second one,
X minus 1.
awesome. So now carefully determine the numerator and give it to me when you're ready. So how do I start? Minus. Now it is wise to perform this operation because I know when I multiply these two, I know what I get. I get minus 1. X squared minus 1. But yes, you're right with minus in front. Minus x squared plus 1. The next step, I combine like terms. These two go away. Now I don't like it because they're not in descending order. So this is negative x squared plus x divided by x minus 1 squared. Now I don't like the top because it has a negative leading coefficient, so I'm going to factor it out. And also x. What is left in parentheses? Perfect. I already stated my restriction. I'm safe. To do what? This is not an equation. Careful. This is just an expression we're asked to perform the operations. But yes, if I were given something equals something else, when I move this to the other side, then I would have to have 0. So the only thing that I have to do now is this. Remove a factor of x minus 1 from the top and the factor of x minus 1 from the denominator. So what is the simplified form of whatever this expression is? Very good. This is it. With this. Awesome. So now let's work on a few rational equations. And that's 7.5. So let's start with problem 50. On the same page, 506. 2 divided by x minus 3 minus 4 divided by x plus 3 equals 8 divided by x squared minus 9. If we did this problem, we can choose another. I don't remember. Say it again. I recommend that method. I recommend moving this term to the other side and set equal to 0. Yes, I recommend that.